Hi everyone, I'm Professor Casey, and this is a quick review on how to do file I/O and how to use text docs. So we're going to be going through the 4 steps that we use to do file I/O. I have them listed out here. The first step will always be to declare a file pointer. The second step will always be to open the file in whatever mode that you need to open it in. Remember, if you open it in read mode, you have to check and see if that file exists. The third step will be to read or write the data, depending on if you're using your file pointer as an input or an output. And the last step, don't forget, very, very quick at the end, is to close your file using your file pointer. So I'm going to walk you through a quick example here, and hopefully this will help shed some light on how to use text docs and how to use both input and output file pointers. Let's get started. So you can see here, I've just declared a couple variables, x and y. These are arrays. I'm going to say that I have some data that I need to read in. Maybe that data looks something like this, where I have 2 columns, like an x and y column. Okay, I've also declared some counter variables, and in n, I know I'm going to use n because I need to know how long my array actually is. We're going to assume I don't know, but I know that it's less than 20. The very first thing I need to do is declare my file pointers. Now, the goal of this program is not only going to be to read in from a file pointer, but I also want to write out to another file, a different file, using a file pointer as well. So we'll walk through that. Let's start just though with the input file pointer. So remember, these usually start with FP, and I have to use that all caps file designation. Right, so we're just declaring them. I'll just declare one for now. We'll just do the input one. So step 1, declare your file pointer. Step 2, I know I'm going to have to read in the data. So that means I need to use my file pointer to open the file in read mode. So now I use that file pointer without the star, right? This is just holding the address of the file. And I'm going to use the command fopen. And my file, I haven't named it yet, but I'm going to call it data2.txt so I can show you how to manipulate some text files. I need a comma, and then I need to tell it what mode I'm going to open it in. And in this case, I'm going to open it in read mode. Now, because I'm going to open it in read mode, I also need to check and see if that file exists. So how I can do that, the easy way to do it, is to see if that file pointer ends up being null. And if it does end up being null, then I know that this didn't read incorrectly, so that file doesn't exist. And if it doesn't exist, I need to print out a message that says something like error, the file does not exist. Exit. And how I exit is just using the command exit -1. Okay, I'm going to add a new line here. So in that case, if the file doesn't exist, it won't just keep running my program while I have no idea what's wrong. Step 3, if you remember, is actually scanning in all that data. Now, if you remember from the lecture, there are a couple different ways to do this. My favorite way is with the for loop. And I'm actually just going to copy this in from my other program I have here. I don't want to have to type that all out if I don't have to. I'll walk you through it though. So for loop, n equals 0, that's just my counter variable. While I'm scanning, right? While this is my whole condition right here, all of that. So my scan from my file pointer of my 2 variables, x and y, isn't equal to EOF. So that means I'm continuing to scan as long as I haven't reached the end of file, that's EOF. And I'm going to keep incrementing n. And once this loop is done, I will have read in all the data in there. And then I'll know how long the file is because I'll know what n is. And you don't have to do this, but I'm actually just going to print this out for clarity's sake, which sometimes I'll do during troubleshooting. So and I declared n as a counter, so it's going to be integer variable. And I'm just going to print out n so that I know how many times it actually looped. You don't have to do that, it's just kind of a check. Another thing you don't have to do that I'm going to do, so I can kind of highlight some loops here, is print out the data. So I wouldn't actually have to ever know what's in that file. It'll just scan it in for me and store it in my arrays. I don't need to print them back out, but sometimes it's nice to actually know what's in there so you know what you're working with. So I'm going to do that. Now remember, with arrays, we have to use for loops. Now, because I have 2 arrays and they're not multidimensional or anything, I really only need 1 for loop. I already set up I as a counter variable at the beginning. Now, this is the question here. How long are you going to loop this for loop for? I don't need to loop for 20 because I don't know that my array is actually 20 long. I only need to loop it until it's less than n, because that's how many variables I actually have in that file. So that's why n becomes useful. N is not any actual data, it's just the number of lines in that file. So I know I have to loop for that many times to print out all my data. And then I'm just going to print out and I've printed those with floats, so I'll just use %f and probably new line's a good idea. And then I'm going to print out x, but remember I can't just use the letter x because that would actually be a pointer. I have to print out xi. And same thing for y. Okay, I'm also going to put a new line here. All right, so that's just printing that data out and making sure that I know what's in there so I don't, mess something up. The last thing we have to do is close the file. And this is actually really easy, fclose. And you use the file pointer name to close the file. So for example, that, right? Super simple. Don't forget to do this though, because it may corrupt your file if you forget to do it and you keep opening and forgetting to close it. Okay, so let's make sure we save this. It's very important to know where you save it because we still have to set up our text file. Now in ZyBooks, it makes it kind of easy on you because you just have to enter the data. But in real life, we don't get to do that. So I need to make sure I remember where I saved this. You can always check. So I saved this in C examples. Okay, so I just make sure I save that there. Sure. Now what I have to do is I need to go inside my file explorer to see examples. Because when this looks for data2.txt, it's going to look in the same place, the C examples, as this C file exists. You can see the name of my C file here is file.io example. So anywhere in this folder, it's going to try and pull. All right. So how do I go about making another file in here? Well, I can right click, I can click new, and I can click text document if you're in Windows, or you can open Notepad. So I'll show you how to do it both ways. So this is going to be data2, right? Remember those names have to match exactly. I have .txt on the end of mine because I've enabled the extensions to show, but as long as it says text document, you may just have to call it data2. If it doesn't work, you probably have data2.txt.txt. Okay, so once I have that in there, I can just open it. I have another text document here with the data that I want, but you can put whatever you want to in here as long as they're floats. Okay, and then I just save that. Now, let's say I'm on a Mac or this didn't work for me with the right click thing. I can also just go down here to my search. You can hit text or you can type in Notepad. Notepad is what you want, WordPad is not what you want. So Notepad, this is just a blank text document. You can start typing columns of words, right? And when you save it, it will just make sure you save it as the file name that you're looking for, right? So you can go here, you can go save as, and then just make sure you save it in that same folder where your actual C file is. But I don't want to save that. Okay. So now let's make sure that this worked. I'm going to build. I have some unused variables. That's okay. It's for my next thing. Okay. And then I'm gonna run it and see what happens. So the total length of the file is 10, and then it's actually spitting out all my data for me because I asked it to print that. Okay, let's say for a minute that I accidentally did something where I haven't set my file correctly. What will happen if I do that? Right now I'm trying to open a file I know doesn't exist. You can see I get that error message and it exited. So that does work. Do make sure that you check that. If you're getting this, you probably haven't named your file correctly or you saved it incorrectly, so just double check. Now I also want to show you how to write an output file. So let's just do that really quick. They follow the same exact steps here. So instead of an input file though, I'm gonna write an output file. I'm gonna actually write into a text document. Can I have both of these in the same file? Absolutely, I can definitely have both of those in the same file. So this is step 1 for both. This is step 2 only for the input file. So this is only for FP1. This is step 3 only for FP1 as well, because I can't scan into an output file, right? Okay. But down here, I can start to maybe modify the data. Let's say I want to subtract 5 or something from each of those data points that I have. This is going to be step 2 for FP2. So just like I did for FP1 up here, I still have to open that file. But in this case, because I'm outputting, I'm going to open it in write mode, not read mode. So I'm actually just going to copy and paste this down because it makes it easier. Change that to FP out, right? This is for my second one. Change that to write, and then I need to change what text document I'm outputting to, because if I left that as data 2, it actually rewrite over everything I just read in. So I usually change this to something totally different. I'm just going to call it output 2 for now. Now, because I'm opening this in write mode, I don't actually have to check and see if this exists, because even if it doesn't exist, it's going to make that file for me, which is super cool. Ooh, I can't spell today. All right, so step 3 for my file pointer 2 is that we have to actually print that stuff out. Now, usually I'll want to modify the data first, so I'm actually going to do that really quickly just with a quick for loop. And I already have my counter variable up at the top set up. So while j equals 0, and remember we're only looping for as many data points as we have. Whoops. Okay, now I'm just going to modify each of these array data points. So I'm going to say, for example, x of j is x of j plus 5. Oops, outside of the bracket. And y of j, right, same counter variable because I want to do them together, equals y of j. And let's just make something up -2 or something. It doesn't really matter. I'm just showing you that you can modify these. So now that I've modified them, I actually have to print them out. And the printing of them out is actually really step 3. So I'm going to move this down here. Okay, so how do we do that? We need yet another for loop, right? With arrays, we always use these for loops. I already have my counter variable set up at the top for k. So I have k is less than n again, right? Because we're just looping the number of times that we have data for. We don't want to loop extra. K plus plus. Ah, I did that again. And then in this case, right, we're printing. We want to output the data. So fprintf instead of fscanf. And remember with fprintf, it's even telling me right here, I need that file pointer first. So fp out, right? And then I need whatever I'm printing, and I know I'm printing floats. %, wow. Okay. And then I need to tell it what it's actually printing. And so in this case, it'll be printing x of k and y of k. All right, and then the very, very last step, step 4 for both of them in this case, we have to close that file as well. So fclose, fp out. All right, so if you want to set up that text document as practice, we can do that, and I can show you how to do that. This also will be put in the same file folder as wherever you saved this file. So here we can go and open RSC examples for me wherever you saved it. This is how I like to do it because it's quick and easy, right? Text document. I need to call this output 2. And now I know that that's there. It would create it for me if it doesn't. You can even try and look and see if it does. Okay, so I'm gonna build this, make sure I didn't make any crazy errors. All right, now when I run this, am I actually gonna see anything different print on my screen? No, it looks exactly like it did before, right? This looks exactly the same, but now if I go and open my output 2 text file, I can see I have data in there. I can also see I forgot to add a new line. Rookie mistake, whoops. Definitely need to add that in. So we'll rerun that so I can show you. And remember, I'm writing to the same file, it's just gonna overwrite it. I don't have to do anything special. So I'll run that again. Again, nothing changes here because we're actually modifying stuff inside the file itself. Ah, that looks much better. So you can see I added 5 to everything here. I subtracted 2 from everything there. If you want to see the original data, that's what it pulled from. Now I can print this to only print 1 decimal if I wanted to, but it's a float, so it prints 6 or 7 on its own. All right, so I hope that you found that useful. That was just a quick example and review of file pointers, file I/O, text documents, and a little bit about arrays too, because if we're reading in data, we're probably going to be using arrays and loops. If you have any questions, feel free to leave them below. I do check the comments, or else you can also email me. Again, I'm Professor Casey, and thanks for joining me today.